Centerline Thrust. In the 1960s, it was supposed to be the holy grail of aviation safety. A design so brilliant it would end the deadly reputation of light twin-engine aircraft forever. But for Cessna, their safer twin became a billion-dollar trap. It was an airplane that cheated the laws of physics only to be killed by the laws of the market. This is a story of the Cessna Skymaster, the masterpiece that was born to fail. To understand why the Skymaster exists, you have to understand the deadly yaw, Centerline Thrust. In the 1960s, it was supposed to be the holy grail of aviation safety. A design so brilliant it would end the deadly reputation of light twin-engine aircraft forever. But for Cessna, their safer twin became a billion-dollar trap. It was an airplane that cheated the laws of physics only to be killed by the laws of the market. This is a story of the Cessna Skymaster, the masterpiece that was born to fail. To understand why the Skymaster exists, you have to understand the deadly yaw. In the 1960s, flight training was brutal. Instructors would pull an engine on students right after takeoff. In a traditional twin, like a Beechcraft Baron, the remaining engine would push the plane sideways, leading to a violent roll and a fatal crash. In the 1960s, flight training was brutal. Instructors would pull an engine on students right after takeoff. In a traditional twin, like a Beechcraft Baron, the remaining engine would push the plane sideways, leading to a violent roll and a fatal crash. Cessna's engineers had a radical idea. Why put the engines on the wings? Let's put them in a line. One tractor engine in the nose, one pusher in the rear. If one fails, the thrust stays in the center. No roll, no yaw, no disaster. On paper, it was the perfect solution. The Cessna 337 Skymaster was a marvel. It featured a high cantilever wing for massive visibility and a push-pull configuration so unique that the FAA actually had to create a brand new pilot license just for it, the Centerline Thrust rating. It could carry 6 people, hit 200 miles per hour, and operate from short, rugged strips. It even went to war in Vietnam as the O2, proving its toughness as a forward air control workhorse. But the transition from the battlefield to the backyard pilot was where the dream started to crumble. So if it was so safe, why did it become a commercial disaster? The first problem was invisible. In a normal plane, you hear and feel the engine in front of you, but in the Skymaster, the rear engine is buried behind the cabin. Pilots would taxi on a hot day, and the rear engine, lacking airflow, would overheat and quit. Pilots would then initiate a takeoff, oblivious that their safety engine was dead. Attempting to lift 4,600 pounds on just the nose engine led to a series of high-profile runway overruns. The very design meant to save lives was now creating its own unique brand of danger. Then came the maintenance trap. While the Skymaster was designed to be easy to fly, it was a nightmare to own. 2 engines, 2 fuel systems, and a complex hydraulic gear system borrowed from the Cessna 210 meant the mechanic bills were double those of a single-engine plane, without the speed of a traditional twin. By the time production stopped in 1982, the Skymaster was caught in a niche nobody wanted. It was too weird for the airlines and too expensive for the weekend pilot. Cessna had solved the problem of asymmetric thrust, but they couldn't solve the problem of economics. The Cessna Skymaster remains one of the most unique silhouettes in the sky, a reminder of a time when Cessna tried to change the world, only to realize the world wasn't ready for the trade-offs. It was a brilliant machine, but it was doomed by its own complexity. If you want to see how Boeing fell into a similar trap in the modern era, watch this video on the China gamble right here. Thanks for watching KineticSkyy. Centerline Thrust. In the middle of the Cold War, aviation engineers believed they had finally cracked the code to one of flight's most terrifying problems, a single design choice that could eliminate one of the deadliest failure modes in light aircraft history. It wasn't just innovation, it was a promise to make twin-engine flying survivable. Cessna didn't just want to improve safety, they wanted to erase fear from the cockpit entirely. What they created instead was an aircraft that defied aerodynamic convention and collided head-on with economic reality. A plane that outsmarted physics but couldn't outsmart human behavior or market forces. This is the rise and quiet collapse of the Cessna Skymaster. To understand why this airplane ever existed, you need to understand the killer that haunted flight schools in the 1960s: asymmetric thrust. Back then, multi-engine training was brutal. Instructors routinely simulated engine failures immediately after takeoff, the most vulnerable phase of flight. In a traditional twin-engine aircraft, losing one wing-mounted engine didn't just reduce power, it created violent imbalance. The remaining engine shoved the airplane sideways, the nose yawed, one wing stalled. The aircraft rolled aggressively toward the dead engine. If the pilot hesitated for even a second, the airplane flipped into an unrecoverable spin. Many never made it back to the runway. Cessna engineers asked a dangerous question. What if the problem wasn't pilot skill, but engine placement? Why mount engines where failure creates chaos? Why not line them up perfectly with the aircraft's center of gravity? Their solution was radical. One engine in the nose to pull, one engine in the rear to push. No wings, no asymmetry, no yaw.